Computer science is the study of the theory, experimentation, and engineering that form the basis for the design and use of computers. That was from Wikipedia.
Hey there. I'm here to tell you about the computer science academic discourse and what it means to write a paper for other computer scientists to read. Similar to most academic papers, computer science starts from the top of the page with the publication in which it is being presented or initially published. Below that, you're going to notice the title, and then the subcontext of that title that will explain kind of what they're getting into regarding that particular subject in computer science. Because, of course, computer science is very diverse. There's a lot of things, from augmented reality to blockchain, and all of these papers need to follow a similar format, so no matter who the computer scientist is that's reading it, they can understand the structure of it and know exactly how to address this paper and understand the new technology. In a lot of the cases, you will notice that somewhere by the author's name, usually to the right, it will actually tell you what university, company, or research team they are from, so that you can get a quick idea of credibility based on who is funding this and sponsorship, who are the people that are trying to address this, are they biased? And you can find out a lot just from that and a quick Google search. So, of course, many concepts in computer science can be complex. So, for readers that may not understand the concept yet, or someone from a different part of the field, they will have the opportunity to get this section called an abstract, where the engineer or computer scientist writing the work will explain the concept behind it before the article starts. That way you can get kind of an idea of why they're talking about the things they are in the upcoming sections. In a lot of cases, below the abstract, they will include some of the terms that they're going to use. And this way, you also can just have the, not just why it matters, but just what it is. But, you know, most of the time they don't give the definition, so that is assuming you can burden yourself with the ability to copy, paste, and then Google search it. So that's up to the reader's discretion. So once we get into the body of the academic computer science publication, we will notice that they tend to have a two-column view. And of course you're supposed to read it chronologically first, top to bottom on the left half, then the right. But usually they'll start with some form of an introduction. They'll explain some background, why, and then they'll give more details on who's involved. Sometimes they'll credit the papers towards the beginning if they're critical to the reader to further research the topic. And then, of course, seeing that this is written by engineers for engineers, after the introduction, we're going to get into sections. And usually there will be subsections, bulleted lists, introductions for each section, and then, of course, subsections in each section will have their own titles and descriptions and introduction and detail. And that way you can easily reference the things that are relevant to what you need to know regarding this technology as a fellow engineer, maybe someone that's trying to build on top of it. Of course, in computer science, being specific is very important. So a lot of these subsections need those headers, descriptions, and things to describe the sub-concept behind the main idea that the journal will be about. Something I found unique in computer science academic papers is the fact that there tends to be a lot of images, no matter who's publishing it. They tend to describe the technology visually to help people understand. And I feel like that's going to help a lot of engineers and regular people understand complex technologies in new ways. For example, this overlay is part of a technology I read in an article called augmented reality, as was the sky map at the beginning of this video. As most of the papers come to a close, they tend to have a conclusion paragraph or section, depending on how extensive the article and topic is. In a lot of cases, they will put another bulleted list explaining what they have done as well as an explanation and a summary of what has already been discussed in the paper, just as a reminder. The last page of each of these papers tends to be a references page, and scattered throughout most of these articles are a bunch of numbers in brackets, and those each relate to a number in the references section. This way they don't need to clutter up the article with in-sentence citations and things like that, because in computer science, obviously, there's going to be a lot of things to reference. Everything builds on each other, and, you know, credit is credit. You got to give it where it's due. Of course, like many, or pretty much all academic papers, computer science does relate everything back to ethos, pathos, and logos. You end up with the author's accreditation, where they went to school or where they worked, as ethos. They have credibility if they explain the topic in a sophisticated and proficient way, things like that. Logos is going to be the engineering examples, math, things like that, explaining how it works and why. And then, of course, pathos is going to be real-world examples, how these technologies can help people and eventually make the world a better place. I hope this video helped you understand the computer science academic discourse and the reason why computer scientists write these papers the way they do for journals. Thanks for watching. I'll put references to some of the articles that I personally read below in the description. Thanks for watching.